Every single photo you take, every image you share online, it goes on this incredible, invisible journey. It gets shrunk, squeezed, and compressed so it can fly across the internet and actually fit on your phone. Today, we're diving into a new algorithm that promises to do all of that better, faster, and way more efficiently than anything we've seen before.
Come on, of course you have. We all have, right? That dreaded storage almost full notification. It's a universal pain. And what's the biggest culprit? 9 times out of 10, it's our massive, ever-growing library of photos and videos. I mean, the sheer volume of high-resolution images we're creating every single day is just staggering. It's a data explosion. And that demands some seriously clever ways to store and send these files without, taking an eternity or completely maxing out our data plans. And that, my friends, is where image compression comes in.
Okay, so at the heart of all this is a really big trade-off. On one side, you've got lossy compression. Think of your standard JPEG file. It makes files super tiny by basically throwing away data it assumes you won't miss. It's fantastic for speed, but here's the catch. That data is gone for good. Then, on the other side, you have lossless compression, like a PNG file. It's perfect. It can reconstruct the original image down to the very last pixel. The downside? The files are a whole lot bigger.
So that begs the question, right? Can we have it both ways? Can we get those tiny file sizes of lossy compression, but with the perfect, pristine quality of lossless? That's kind of the holy grail of this field, and it actually has a name. It's called near-lossless compression. The goal here is to be incredibly clever. You shrink the file by getting rid of data, but only the data that our eyes literally can't perceive anyway. So you get this huge savings in space, but when you look at the picture, it looks absolutely perfect.
And this is where our story really kicks off, because we're looking at a potential breakthrough in this area. It's a new algorithm that aims to master this perfect balance, and it's called RIFD-DLT.
So what is RIFD-DLT? Well, it's a hybrid. It's not just one new idea. Instead, it's a really powerful combination of 2 existing techniques that have been layered together to create something way better than either one could be on its own.
Let's just break down that name for a second, because I know it's a mouthful. The RIFD part stands for rounding the intensity followed by dividing, and DLT is short for Delta Encoding. Separately, they're pretty useful tools, but put them together, that's when things get incredibly efficient.
Okay, so let's get into the nitty-gritty, because the way these 2 steps work together is really the secret sauce here. It's brilliant. First up is the RFID step. Think of it like a tidying up phase. It goes through the image and slightly simplifies the color palette, rounding off color values in a way our eyes will never, ever notice. This basically preps the image for the next, even smarter step. That's when Delta Encoding comes in. Now, instead of writing down the full color value for every single pixel in the image, it just writes down the tiny difference from the pixel in the row right above it. It's a genius kind of shorthand that saves a massive amount of data.
So, all of that sounds fantastic in theory, but how does it actually perform in the real world? Well, the researchers put RIFD-DLT head-to-head with other algorithms using standard image datasets to see just how much it could shrink a file.
And the results are, well, they're pretty dramatic. Just look at this. Using the standard Kodak Image set, the older RIFD-Huffman method got the files down to about 4,000 kilobytes. A competitor, like a CS, did better at 3,300. But RIFD-DLT, it absolutely crushed them, squeezing the exact same images down to just 2,131 kilobytes.
Let me put that another way. We're talking about a data reduction of nearly 82%. It took the original 11,520 kilobytes of image data and basically made it disappear, shrinking it by more than 4/5. That's huge. And get this, it doesn't just save space, it saves time. Across 3 different sets of images, this new algorithm finished the entire job, compressing and decompressing over 16 seconds faster than its direct predecessor. So it's not just smaller, it's quicker.
But this is the million-dollar question, isn't it? We've got smaller files, we've got faster speeds, but did we have to pay for it with blurry, weird-looking images? What happened to the quality? And the answer is absolutely nothing. This is honestly the most impressive part. The peak signal-to-noise ratio, or PSNR, is just a mathematical way to measure image quality. And if you look at the numbers, they're identical. RIFD-DLT is identical to the older method. It achieved a massive improvement in compression with literally 0 additional quality loss. It's a genuinely free upgrade.
So,
Okay, a faster, more efficient algorithm is obviously great if you're a computer scientist. But what does it mean for the rest of us? Why should you care about this in the real world?
Well, it means pretty much everything gets better. It means your high-quality photos upload and download faster. It means cloud services like Google Photos or iCloud can store more of your memories for less money. In really critical fields like remote sensing or medical imaging, it means vital, life-saving data can be sent more quickly. It literally reduces the strain on our entire digital world.
RIFD-DLT is a really significant step forward. It's just an elegant solution to a massive data problem. And it makes you wonder, as we generate more photos and videos than ever before in human history, what clever combination of ideas is going to come next to keep our digital world from completely overflowing?